Hello students, I am Dr. Satish Chauhan, your chemistry teacher. I welcome you in the video lecture 4 of the modern approach to the chemical industry. In this video, we will learn the selection parameters of chemical industry, types of chemical reactions and concept of conversion, selectivity and yield. Selection parameters of the chemical industry. The selection parameters are plant location. प्लांट कहाँ पे लोकेट करना है, जहाँ पे द ट्रांसपोर्ट फैसिलिटीज आर अवेलेबल, रॉ मटेरियल्स आर इजीली अवेलेबल, देयर इज अ सोर्स ऑफ पावर is available and so on. So selection parameters: plant location, availability of raw materials, market facilities and other facilities. Let us consider the second is the safety measures. Safety measures include some equipments and hospital facilities, and all these transport facilities are required for safety measures also. Next is the construction of the plant. प्लांट कहाँ पे कंस्ट्रक्ट करना है, जहाँ पे रॉ मटेरियल्स अवेलेबल है, मार्केट फैसिलिटी अवेलेबल है, अदर फैसिलिटी अवेलेबल है, ट्रांसपोर्ट फैसिलिटीज आर अवेलेबल. At that site you can construct the plant. Management for productivity. For production of chemical, what you will require? Management. So management involves the president, vice president, HRD officer, quality control officer, production chemist, workers, all. So that is called as the management for productivity of the particular chemical. So that is the selection parameter. We have to select the particular persons for who are working properly for proper things. Then training facility. Training facility should be made available in the industry. जो नए लोग अपॉइंट होकर आ गए हैं उनको काम करने का कोई पता नहीं होता है सपोज, तो व्हाट वी हैव टू डू इज वी हैव टू ट्रेन देम. So company should have the training facility to newly appointed workers. The chemical process technology. कौन सा भी chemical production करने के लिए what will require? You will require some chemical procedure. So that chemical procedure involves the technology changes and all the change जो भी होगा वो. So that is the chemical process technology. The classification of chemical reactions. The chemical reactions are classified as two types: homogeneous reactions and heterogeneous reaction. Homogeneous reactions, these are classified as catalytic reactions and non-catalytic reactions. Heterogeneous reactions are classified as gas liquid reaction, gas solid reaction, liquid solid reactions and gas liquid solid reactions. So let us consider homogeneous reaction. A reaction that involves single phase is called as the homogeneous reaction. These are classified, as we have said, catalytic reactions and non-catalytic reactions. So catalytic reactions, the examples of catalytic homogeneous reactions in the liquid phase are nitration, sulfonation, Friedel-Crafts acylation and alkylation, esterification, enzyme reaction, etc. So these are the catalytic reaction. Suppose we have Friedel-Crafts acylation reaction. In this, what we use? The aluminum trichloride that is used as a catalyst. So this is catalytic reaction. Non-catalytic reaction. The example of non-catalytic homogeneous reactions are in gas phase are combustion, pyrolysis, cracking and acid base reactions. So these are non-catalytic reactions. Second type is the heterogeneous reactions. The reactions involve two or more phases. These are called as the heterogeneous reactions. The gas liquid reaction, so more than one phase are there, so gas and solid phase reactions are there. The catalytic reactions are oxidation, alkylation, polymerization, halogenation, ammonolysis, etc. And the non-catalytic reactions are absorption of gases like Cl2, CO2 in NaOH or NH3 in H2SO4, HNO3 and H3PO4. So these are the non-catalytic gas liquid reactions. Then gas solid reactions. The catalytic reactions are ammonia synthesis, hydrogenation, halogenation, oxidation of SO2, NH3, etc. Non-catalytic reactions are the reduction of metal oxides, burning of coal, roasting of iron. Liquid solid reactions, catalytic are polymerization using Ziegler-Natta catalyst, enzyme catalytic reaction. Non-catalytic reactions are leaching of ore by acids and ion exchange reactions. Gas liquid solid reactions, catalytic reactions are gas liquid catalyzed by the solid, for example oxidation and hydrogenation of organic compounds, that is vanaspati oil to vanaspati ghee. So let us consider the two types of the processes. So production of chemicals or chemical production of chemicals is done by the two processes, batch process and continuous process. Batch process is the calculated amount of the raw material is fed into the one lot and then products are removed after some time. जो products हम batch wise कर सकते हैं, आज 4 घंटे में पहला बैच हो गया, उसके बाद दूसरे 4 घंटे में दूसरा बैच हो गया, तीसरे 4 घंटे में तीसरा बैच हो गया. So that is the batch wise production of the chemicals. So in that calculated amount of the raw material is fed in one lot and the products are removed after completing the reaction. So that is the batch product. Let us consider the continuous process. The calculated amount of the raw materials is fed continuously and the products are removed continuously. यहाँ पे एक ही प्रोडक्ट हम मैन्युफैक्चर कर सकते हैं 24/7 into 365 days. So 24/7 into 365. So that is the continuous process. एक ही प्रोडक्ट, एक ही रॉ मटेरियल इसमें हम कंटिन्यूसली डाल देते हैं और वी आर गेटिंग द सेम प्रोडक्ट थ्रू आउट द ईयर 24 hours. So that is called as the continuous process. In batch process क्या होता है फिर? The apparatus and equipments remain idle during the charging and discharging. बैच प्रोसेस में हम क्या करते हैं कि 4 घंटे में पहला प्रोडक्ट निकालते हैं, उसके बाद दूसरे 4 घंटे में दूसरा प्रोडक्ट निकालते हैं. So what will happen? For production of the particular chemical we require some time. प्रोडक्ट निकालने के लिए आपको टाइम लगेगा, प्रोडक्ट डालने के लिए रिएक्टेंट डालने के लिए टाइम लगेगा. सो ड्यूरिंग दैट प्रोसेस द apparatus and equipments remains idle, means stable, जैसे कि वैसे रह जाते हैं. So that is called as idle during the charging and discharging of the materials. The apparatus and equipments never idle during the charging and discharging, as it is a continuous process. Charging and discharging takes place simultaneously. No instrument remains idle. Charging and discharging is tedious and requires more manual labor. एक तरह का प्रोडक्ट निकाल लिया फिर दूसरा बाद में तैयार किया, इसलिए आपको क्या लगता है that charging and discharging process is tedious, वेळ खाऊ प्रोसेस असते, ज्याला जास्त माणसं लागतात, या ठिकाणी मनुष्यबळ त्याला जास्त लागतं. अशा प्रकारची प्रोसेस म्हणजे बॅच प्रोसेस. द चार्जिंग अँड डिस्चार्जिंग इज इझियर अँड रिक्वायर लेस मॅन्युअल लेबर. इट कॅन बी डन ॲटोमॅटिकली. ॲटोमॅटिक कंट्रोल्स तर त्याच्यामध्ये सेट करून ठेवले आपण, तर चार्जिंग अँड डिस्चार्जिंग ॲटोमॅटिक होऊन जातं. त्याच ठिकाणी एक माणूस असला तरी पुरेसा असतो या ठिकाणी. सो दॅट इज अ कंटिन्युअस प्रोसेस. द टेम्परेचर, प्रेशर, कॉन्सन्ट्रेशन, रेट ऑफ रिएक्शन may not remain constant in all batches. Temperature, pressure, concentration, rate of reaction may not remain constant for all batches because batch to batch human workforce is changed. काम करणारी माणसं त्या ठिकाणी शिफ्टमध्ये चेंज होतात. सो दॅट द टेम्परेचर, प्रेशर, कॉन्सन्ट्रेशन एकच राहिल्याची याची खात्री देता येत नाही. Here the temperature, pressure, concentration, rate of reaction etc. are always remain constant throughout the operation. The process is good for, not good for bulk chemical production. बल्क प्रोडक्शन म्हणजे काय, खूप मोठ्या प्रमाणामध्ये तुम्हाला जर केमिकल तयार करायचं असेल तर बॅच प्रोसेस काय या ठिकाणी दिस इज नॉट युजफुल. But if we have to manufacture various products, so let us manufacture one product for 10 days, another product for 10 days and another product for 10 days continuously. In that way a batch process या ठिकाणी चांगली या ठिकाणी आहे. The process is good for bulk chemical production but not good for small amount of the specialty chemicals. The quality control is difficult. Quality control is high quality product is obtained. Generally cheaper setup costs, higher initial setup cost is there. Employee understand the process well. Employees knowledge of the process is limited because this is all automatic. The variety of the products using the same equipment are obtained. Variety of the products using same equipment are not possible. Less profitable process, this is more profitable process. Scheduled maintenance and inspection to equipments in the between batches is possible. Maintenance and inspection दोन्ही बॅचच्या मध्ये आपल्याला करणं पॉसिबल आहे. या ठिकाणी मात्र तसं पॉसिबल होत नाही. पेरियोडिक शटडाउन इज रिक्वायर्ड फॉर द scheduled maintenance and inspection to the equipment. Conversion, selectivity and yield. So what is conversion? Conversion refers to the amount of reactants consumed or converted into the product, which is given as percentage conversion is equal to number of moles of reactant reacted divided by number of moles of the reactants used into 100. So that is conversion. Selectivity. The selectivity of reaction is the ratio of the desired product formed in moles to the undesired product formed in moles, which can be given by the formula percent selectivity is equal to number of moles of desired product formed divided by number of moles of undesired product formed into 100. Yield. The yield means the amount of specific product produced during reaction. It is given by the formula percentage yield is equal to number of moles of desired product actually formed in the reaction, that is practical yield, divided by number of moles of desired product, that is theoretical yield, into 100. Let us consider this reaction. This is the reaction of aniline with nitrotic mixture at 0 to 5 degrees Celsius, giving rise to the product para-nitroaniline. Practically, it should be assumed that the 1 mole of aniline should give 1 mole of the para-nitroaniline as a product, but it is not practically possible. So, it is observed that nearly 0.8 mole of product, that is para-nitroaniline, is formed. So, how to calculate the percentage yield? The number of moles of desired product actually formed, that is practical yield. So, what is the practical yield? It is 0.8 divided by number of moles of the product, theoretical yield. So, 0.8 divided by 1 into 100. So, that will be the 80%. So, the percent practical yield will be 80%. Dear students, in this video we have learned the selection parameters of chemical industry, types of chemical processes, batch process and continuous process, and we have also learned the concept of conversion, selectivity and yield. Thank you for watching this video. We will meet in the next video. Till then, it's bye from me.